This is Algebra 2 Homework 9-3, Inverses of Functions. All right, so we're trying to find the inverse of each of the functions for numbers 1 through 4. So the general idea here is we're going to switch our y-coordinate and our x-coordinate. The y-coordinate is really g of x. So I'm going to say that this is now x, and that's going to be equal to negative 5 halves. And instead of x here, I'm writing the y-coordinate, which now, instead of being g of x, is g inverse of x, because we've officially switched it, plus 15 halves. All right, so I need to undo things happening to g inverse of x. The first thing that I do if I'm undoing PEMDAS is getting rid of addition or subtraction. I'm going to get rid of this addition by subtracting 15 halves to both sides. So minus 15 halves, minus 15 halves, and that's going to leave me with x minus 15 halves, and that's going to be equal to negative 5 halves of g inverse of x. And then to get rid of this negative 5 halves, I can do that all in one fell swoop, and I'm going to show you how to do that. It'll make sense if I move this over a little bit. So if I were to multiply this by 2, then these 2's would cross cancel. If I were to divide this by a negative 5, then these negative 5's would cancel. And by the way, I arbitrarily put the negative on the top. You can choose to put the negative on the top, the bottom, or out in front. All of them are the same as long as you only do one of them. So from this, I have a negative 5 down here. That's going to cross cancel. So this is the number that I multiply both sides. That means the right is being multiplied by 2/5, or negative 2/5. The left is also being multiplied by this negative 2/5. And that's going to give me this g inverse of x. And I am going to distribute. I have a negative 2x over 5, or negative 2/5 x. And if I distribute over there, I'm seeing that this 2 and this 2 cross cancel. The negative and negative cross cancel, meaning I have a plus. And then 5 and 15 are going to cross cancel, so I have a 3 here. So I get negative 2x over 5 plus 3. Let's check. Negative 2/5 x. And then plus 3. Is that what I said? Negative 2/5 x plus 3? That is okay. Negative 2/5 x plus 3. That is the correct answer. Cool. All right, what about number 2? In number 2, we need to, again, switch the x-coordinate and the y-coordinate. So I now have x is equal to the cube root of this entire fraction of h inverse of x minus 3, all of that divided by 2. The first thing I'm going to do to both sides is get rid of this cube root by taking both sides to the power of 3. This is going to be power of 3, and I have x to the power of 3 on the left, and now these cancel out, meaning I have just an h inverse of x minus 3 all over 2. The next thing that I need to get rid of is this divided by 2, so I'm going to multiply both sides by 2, multiplied by 2. So I now have 2x cubed is equal to h inverse of x minus 3, and then finally I'm going to add 3 to both sides, plus 3, and my final answer is going to be 2x cubed plus 3 is equal to h inverse of x. Final answer, I'm going to box it. Let's check. 2x cubed plus 3, 2x cubed plus 3, we got it. All right, for number 3, this one is really tricky. I didn't cover this one in the notes. It's probably one of the harder questions on the homework assignment. Again, you have to start by switching your x and your y coordinates. So we have x is equal to negative 1 all over f inverse of x plus 1 minus 1. The very first thing that we can do is get rid of this minus 1 by adding 1 to both sides, plus 1, plus 1. So now I'm left with x plus 1 is equal to this negative 1 all over this f inverse of x plus 1. The very next thing that I want to get rid of is this negative on the outside, so I'm going to multiply both sides by a negative 1. So multiply by negative 1 over here, multiply by negative 1 over here. Remember, I'm really distributing into that entire side. So negative 1 and that negative are gone, and I'm left with a negative x minus 1 is equal to 1 over f inverse of x, and then plus 1. Okay, this is the hard part of the problem where we don't know what to do, because our thing that we're trying to solve for, this f inverse of x, is trapped on the denominator. So in order to untrap this, I'm going to take the reciprocal of the right side. I'm going to switch the top and bottom. If I take the reciprocal of the right side, I also take the reciprocal of the left side, and it's kind of confusing. What is the reciprocal? Well, this is technically over 1, so the reciprocal will be 1 over that negative x minus 1. So the right side is now f inverse of x plus 1 on the top, and on the bottom is now 1. Divided by 1 is the same thing as not having it at all. So there's the inverse. And on the left side, I have 1 over negative x minus 1. Finally, the last step is to subtract 1, which means our final answer, f inverse of x, is going to be 1 over negative x minus 1, then minus 1 off to the side. Got a little bit cramped in there, but I think we got the right answer. So let's check. For number 3, it's 1 over that negative x minus 1 over, okay, they put the negative out here, and they didn't distribute it into both of these terms, but that's okay. And then there's the minus 1. So we still got the same answer, but if we distribute the negative into the bottom, that's still the same thing. All right, let's do number 4. Number 4, again, we're going to switch our x coordinate and our y coordinate. So I'm going to say that this is now x, and that's going to be equal to 2 minus the 5th root here of 16, not x, but h inverse of x. And this is all going to be divided by 2. So the very first thing that I want to do is I want to get rid of this divided by 2. So I'm going to multiply both sides by 2. Multiply by 2, multiply by 2, and I'm now left with 2x is equal to 2 minus the 5th root here of this 16 times the h inverse of x. From here, I'm going to get rid of the 2 by subtracting 2 on both sides. Subtract 2, subtract 2. I have 2x minus 2 on the left. On the right, I have just the 5th root, technically negative the 5th root of 16 h inverse of x. All right, so I want to get rid of that negative. So the way that I'm going to do that is I'm going to just multiply both sides by -1. Multiply this side by -1, multiply this side by -1. And that's distributed all the way through the left side. So it's really a negative 2x plus 2. And the right side is now a positive 5th root of 16 h inverse of x. All right, so from here, I'm going to undo the 5th root by taking both sides to the power of 5, both sides to the power of 5. And then this is going to be 16 h inverse of x. And that's going to be equal to all of that. And I can leave it in that form, but I have a feeling that the answer key is going to want to cancel out that 16. So before I do that, watch what I'm going to do here. I'm going to do an intermediate step to make this easier for myself in the long run. This is going to be, you don't have to do this, but this will make it more simplified. I'm going to factor out a 2, technically a negative 2. If I factor out a negative 2, what's left over is an x minus 1. It's a little bit hard to see, but if I divide this term by negative 2, negative 2's are gone, leaving behind just an x, just an x. If I divide this term by negative 2, 2 divided by 2 is 1, and then positive divided by negative is a negative. So left over is an x minus 1. And this entire quantity is to the power of that 5. Why would I do it this way? Because watch what's going to happen. This 5 is going to distribute to both of these two terms so that I get this. Negative 2 to the power of 5 times x minus 1 to the power of 5. And then negative 2 to the power of 5. Again, anytime I have a negative to a power of an odd number, it's still negative. If it was an even number, it would have been a positive. So this is going to be a negative 32. Again, 2 times itself 5 times is 32. Times x minus 1 to the power of 5, and that's going to be equal to still this 16 h inverse of x. And now I can divide both sides by 16, and it'll work out really nice. Here, I'm running out of room, so I'm going to come and work up here. If I divide both sides by 16, divide by 16, divide by 16, I'm going to get, notice that these will also cross-cancel here. So cross-cancel to just a negative 2 on the top and a 1 on the bottom. So I really have negative 2 times the quantity of x minus 1, that quantity to the power of 5, and that's going to be equal to h inverse of x. And there's my final answer. Let's go and see if it matches the answer key. So number 4 is the negative 2 factored out. Yeah, so they also factored out the negative 2 like I did. You don't have to do it that way, but it is a little bit easier, I think. All right, for numbers 5, 6, 7, and 8, we are trying to determine if it is an inverse. We can plug one function into the other to check that. I am not even seeing the same numbers here. That's a 3. There's no 3's in here, so I'm doubtful that this one is even going to work, but we'll try it. So I'm going to plug this into that x right there. The way that I do that is I say g is plugged into f. So here's f, and then inside of that, I'm plugging in g of x. So I'm going to rewrite f of x right now. F of x is 3x plus 15. So here comes my 3x plus 15. All right, our x in this case is g of x, and g of x is this negative 5x, or negative 5 fourths x plus 5. That's going in here. I have a negative 5 fourths x plus 5. All right, if this thing evaluates to x, we're done, and the answer is yes. I don't see that happening though, because watch. 3 times this is going to be negative 15 over 4x, and then I have to distribute the times here, and that's going to be plus 15, and then I have to copy down this plus 15 down here, which is going to be another plus 15, and this simplifies to negative 15 fourths x plus 30, which is nowhere in the ballpark of x. If it was equal to x, it would be an inverse. So the answer here is no, it's not an inverse. All right, what about for number 6? Very possible, because I see a 2, I don't know where that 16 is coming from, but I see a 2 and 2, a 5 and a 5. Those will probably cancel each other out. I don't know where that 16 is coming from. Let's try. I'm going to plug in, it doesn't matter which way I plug in. I'm going to, just to show that you can go the other direction too, I'm going to plug all of this into this x. So I'm going to say that I'm starting with f of x, and the thing I'm plugging into f of x is g of x. So let me rewrite f of x. F of x is 2x to the power of 5. Inside of that x is g of x. And g of x is this fifth root of 16x, this fifth root of 16x, all of that divided by 2. All right, remember your orders of operations. You do not cancel out these 2's first. You first do this power. This power is going to be distributed to both the numerator and the denominator, which means this is going to be equal to, so I'll have that 2 out front. I have this 5 and that 5 are going to cross off, so I have a 16x at the top, and that's all divided by 2 to the power of 5. So from here, I'm going to multiply. I can now say this 2 times 16 is 32, so I have 32x on top. What about the bottom? What is 2 to the power of 5? That's 32. Oh, and check this one out. 32 and 32 cross cancel, leaving you with an x. The answer in this case is yes, this is an inverse. And I'll box that. Let's go ahead and check those 2 answers. So I said that 5 was no and 6 was yes. 5 was no, 6 was yes. And we can preemptively see yes, no, so we can check those answers. It should be a yes and no. How do we do number 7? And I kind of see all the same numbers. 2, 1, 2, 2, 1, 2, right? Maybe the negatives will mess us up, we'll see. All right, it doesn't matter which one you plug into. I'm just going to arbitrarily say, let's do f of h of x. And that means h of x is being plugged in, right? So h of x is being plugged into f. Okay, let me rewrite f. F is 2 all over negative x minus 2, then minus 1. So what is x? X in this case is h of x. H of x is all of that function which gets plugged into that parentheses. So I have a negative 2 over x plus 1 minus 2. All right, so the very first thing that I see is I can distribute my negative. So negative there will cancel out everything. So really what I have here is 2 all over a 2 over x plus 1 plus 2, then minus 2. What do we do now? From here, I need to somehow get these 2 to be one fraction, because then I can do a fraction divided by a fraction, but this has to be a fraction first. So how do I do that? And I'm going to do some scratch work off to the side. The question right now that I'm asking is, how do I do this problem of 2 over x plus 1 plus 2? In order to add these, they have to be like denominators. This denominator is x plus 1, this denominator is 1 for now. So that means I need to multiply this one by x plus 1 all over x plus 1. So my new problem is really 2 over x plus 1 plus, distributing the 2, 2x plus 2 all over x plus 1. Now I can add them, and I'm going to put that final answer over here. I'm going to say that this one is going to be equal to 2x plus, sorry, I have to write that numerator, don't I? So this is going to be equal to 2 is still the numerator. That denominator has now changed into this thing, which is 2x plus 4 all over x plus 1. Because this is 2x plus 4 all over x plus 1. All right, and then I still have to do minus 2. So from here, I have a fraction divided by a fraction. Technically, this is 2 over 1. Divided by this 2x plus 4 over x plus 1. A fraction divided by a fraction, you keep, change, flip. It's a little bit complicated, but we can do this. Here we go. This is going to be keep it. So it's going to be, I'm running out of room here, but let's try it. It's going to be keep it, 2 over 1, change it to multiplication, and flip it to x plus 1 on the top now, and 2x plus 4 on the bottom. So one thing that I can already see here is that this is going to be, I'm going to distribute this 2 here and here, which means I really have a 2x plus 2 all over a 2x plus 4, and then I need to subtract 2 finally. All right, so I don't see this thing turning into the right number, because what I need to do now is this has to have a like denominator with this. So I need to multiply this one by a 2x plus 4 all over a 2x plus 4. Distributing in here at the same time means I'm going to be doing this problem of 2x plus 2 over 2x plus 4, just rewriting u, minus 4x minus 8. I'm distributing the negative as well. This whole negative is being distributed. And then that's all over 2x plus 4. Salut. All right, so from there, what are we going to have? I am running out of room, so I'm going to work up here now. I have some blank space. 2x minus 4x is negative 2x. 2 minus 8 is negative 10. And that's going to be all over 2x plus 4. While I can simplify a little bit by factoring out a 2 and saying that this is the same thing as negative x minus 5 all over x plus 2, this nowhere near x, so the answer here is no. It's not invertible. And I think that's what we saw in the answer key. I hope so. Oh my god, we used way too much space. So number 7, was it no? Number 7 was yes. Oh no, we've made a mistake. Number 7 was yes? All right, I need to find my mistake. Give me a sec. I have to rehash everything that I've already done. So first, did I rewrite my f function first? This is 2 over negative x minus 2 minus 1. Everything right there is x. And I plug u in correctly. It looks good so far. When we distribute the negative, those change signs to both pluses, so they're both positives. Okay, and then from there, we needed to add those 2 together. So I should have gotten 2x, I'm just checking my work up here now. We're adding the 2 together. So it's 2x plus 2, which turns into 2x plus 4, so all over x plus 1. That looks correct, and then you're going to keep it, change it, flip it, keep it, change it, flip it, 2x plus 2. I'm not seeing the mistake. I feel like I would have caught it by now. I guess I'll just keep going, because I'm very confident about all of that math. It has to be up here, right? Where do we go? It's going to be 2. H is the negative out front. Okay, there it is. So, we forgot that negative 2. That negative 2 should have gone right there, which would have made our problem much, much easier. So I apologize if you're following along and had to copy down all of this math up here. We didn't actually need it. It turned out to be really nice, because this, and I'll write it down in here, this has a minus 2 right here, which means these 2 numbers just cancel out. Cancel, cancel, meaning we have, and I need to unfortunately erase all of this math, which is kind of nice because we have more room for number 8 now. Which means I really have, and maybe I can come up there. So we're going to work up here now. And I'm going to say this is really now 2 divided by 2 over x plus 1, and then I have to do minus 2 at the very end. Whenever you do division with fractions, you keep it, change it, flip it. So keep it, change it, flip it, x plus 1 over 2. And then notice that these 2's, I still have to do my minus 2 though, don't I? Minus 2. I'm still going to cross cancel the 2's, cross cancel the 2's. And this is going to be x plus 1 minus 2. And that's going to be, oh wait, it's not minus 2 off to the side, is it? This is a minus 1. I don't know why I keep doing the minus 2. This should be a minus, whoa, that eraser was too big. That should be a minus 1. All of these should be minus 1s. Minus 1, minus 1, minus 1, and that finally turns into x. Yes, there we go. Okay, we got it. The answer here was yes. Took us a little bit of trying, but we got it. Again, if you're following the video and you're catching these mistakes before I'm catching them, then you can log them. If you're catching them after I said it, then that doesn't count as extra credit. All right, number 8, and then we're halfway done with this homework. These are clearly not inverses, and it's pretty easy. If I plug x into x, it's still x. So I'm going to say g of f of x. I'm not going to do colors in this case. is going to be 3x minus 3. You don't even see it, but that 3, or that x right here is really that x right there. That's not x, so the answer is just no. Kind of a nice problem at the very end. All right, now we have 4 graphing questions, which are kind of tricky. So here we go, let's try these. In number 9, we need to find the inverse function first, and then we're going to graph both the inverse function and the normal function. So to find the inverse function, we're going to switch out our f of x. So for an x, we're going to say x is equal to 4 minus 3/4. Instead of f of x, we're going to say f inverse of x for here. Okay, so bringing everything to the other side, I'm going to subtract 4. I have enough room to do this right here. Here, I'm going to go ahead and bring this right here, and I'm going to just work down. So if I subtract 4 on both sides, it's going to be x minus 4 is equal to negative 3/4 f inverse of x. And then from there, I'm going to multiply both sides by 4 and divide by negative 3. Multiply by 4, divide by negative 3, the entire side. Those are gone then, and I have f inverse of x, therefore is equal to a negative 4/3 x. If I distribute, it'll be a positive, I'm running out of room here, positive 16/3. Kind of a disgusting function. Let's go ahead and graph this thing. Okay, so graph whichever of these functions is easiest, and then just invert that table. So I'm going to say that this one is the easiest. So I'm going to say over here, I have x and f of x. The numbers that I would like to plug in, let's plug in like 0, 1, 2, something like that. If I plug in a 0, follow me. 0 is plugged into this x. 0 times 3/4 is 0. 4 minus 0 is 4. Easy peasy. What happens if I plug in 1? 1 times negative 3/4 is negative 3/4, which is about 0.75, right? 0.75. And if I do 4 minus that, I'm about 3 1/4. So that's going to be 3.25. 3.25. All right, what happens if I plug in a 2? If I plug in a 2, and this is kind of silly to do, but I'm just going to finish up 2, and then I'll tell you that this was just slope-intercept form. So 2 up here, that's going to, the 2 and the 4 will cross-cancel into a 3 and 2 now. There's that 3, that 3. So it's going to be 4 minus 3/2, which is 4 minus 1.5, which is 2.5. So I can say 2.5. Essentially what I'm doing is I'm going down 0.75, down 0.75 each time, right? So I can graph these 0, 4, 1, 3.25, 2, 2.5, etc., etc. But really what I should be doing is just using slope-intercept form. Y-intercept is 4, and I go right 4, down 3. So right 4, down 3 is this point right here, and I can just connect these with a straight line. And I should probably extend that as well. Okay, so there's our function. What we need to do now is we need to take the inverse of that table. So what I'm realizing here is that these 2 points are really, really nice, and I know that this is a line, so I really only need 2 points on my next table. I'm going to have x values and f inverse of x values. And these points were 0, 4, so it's now 4, 0. Notice that I've switched 0 and 4 to 4 and 0. And this other nice point is 4, 1. So that originally is up here. 4, 1. I'm going to switch that to 1, 4. So I'm going to graph this one in blue. Let me go ahead and change the color of this table so it matches the color of my graph. I'm going to say color blue. I'm going to say that's going to be 4, 0. So 4, 0. And 1, 4 is up there. And I'm going to connect those with a line like so. I can extend that line up a little bit. And you can see that if I draw the line y equals x, which is supposed to be that function right there. Okay, they're a little bit off. They should have been perfect reflections of each other, and I think that's because this blue line is off a little bit. It should be right about there. So this line needs to be moved right there. Good enough. You can see that they are reflections over that y equals x graph. All right, that was graph 1 of 4. Let's graph another one. Okay, finding the inverse function. So I'm going to switch the coordinates around here. What do we get? We get x value is equal to the cube root of that entire function, which is negative, and then f inverse of x. then minus 2, all of that divided by 2. Okay, let's cube both sides, right? Power 3, and I get x cubed is equal to negative f inverse of x minus 2 all over 2. And then from there, I'm going to multiply this both sides by 2. So I'm going to get 2x cubed is equal to, so multiplying by 2. Those cross cancel, leaving behind a negative f inverse of x minus 2. Let's go ahead and add 2 to both sides. So I have 2x power 3 plus 2 is equal to negative f inverse of x. And then finally multiply both sides by negative 1 to get negative 2x cubed minus 2 is equal to a positive f inverse of x. So we have both these functions. I think that this function right here is the easier one to plug into because I don't know how to do cube roots of random numbers. I know how to do cube root of perfect cubes, but not random numbers. So I'm going to start with a table that does x values and f inverse of x values because that's the easier of the two functions. So what's a nice number to plug in? I think 0 works really nicely. Watch. 0 plugged into my f inverse function means it's 0 cubed, which is 0, times negative 2, still 0, then minus 2 is negative 2. Let's plug in another number, like 1. When I plug in 1, I get 1 cubed, which is 1, times negative 2, which is negative 2, minus 2 again is negative 4. If I plug in a number like 2, I have a feeling this is going to be off the graph, but let's go ahead and test it. 2 cubed is 8, times negative 2 is negative 16, minus 2 again is negative 18. Well off the graph. What about negative 1? If I plug in negative 1, I'm going to get negative 1 cubed, which is still negative 1, times negative 2 is now positive 2. 2 minus 2 is 0. And I have a feeling this is also going to be off the graph, but let's test and see. If I plug in 2, this is going to be 2 cubed, which is 8. 8 times negative 2 is negative 16. Oh, I want to do negative 2. I was like, is it the same problem? There we go. Negative 2. Negative 2 cubed is negative 8. Negative 8 times negative 2 is a positive 16. 16 minus 2 is 14, which is well off the graph. So I can really only use some of these points. 0, negative 2, let's graph. 0, negative 2, it's right there. 1, negative 4, and negative 1, 0. So it's going to be a graph that goes... not my best graph, but it's going to look something like that. And then I need to reflect this, which means if I make a new table of x values and f of x values, I just switch my x and my y's, the only ones that are useful. So negative 2, then 0, negative 4, then 1, and let's do 0 and negative 1. Graphing these points, I get negative 2, comma 0, negative 4, comma 1, negative 4, comma 1, and 0, negative 1. 0, negative 1 is right there. And I'm going to do my best attempt to graph this. I'm going to get this line that looks like that. And I'm in a car, so it's a little bit wavy. And there's my best attempt. And just to do a sanity check, if I reflect over this line, y equals x, it looks about like a reflection.